In this video, we're going to go over some examples of order of operations with rational numbers. So if you recall, you have some rules for adding and subtracting fractions, for multiplying fractions, and for dividing fractions. The most important thing is that you need a common denominator. So that would be step number 4 up here. Before you can add or subtract. And then for multiplying and dividing, you do not need a common denominator. Makes your numbers very, very large to work with and very challenging. Okay, so let's do some examples. In the first one here, we're going to evaluate. So what I notice here is that I'm multiplying. So here I'm going to check for canceling. So I see that I've got 4 and then 12 diagonally across. I can divide this part by 4, leaving me with 1. I can also divide 12 by 4, leaving me with 3. Now I can multiply the numerators together to get minus 14, and then multiply the denominators to get to 21. What I can see here is that I can also divide by 7. So now I've got minus 2 over 3, which if I'd noticed, I could have done that up here and canceled across. Example 1b, here I've got a division, I have a whole number, and I have a mixed number. So the first thing I'm going to do is I'm going to change my whole number to a fraction. And then what I'm going to do is I'm going to change my mixed number to an improper fraction. So 1 times 4 plus 1 is 5/4. Then I'm going to change the sign. Change the sign. And invert my second fraction. Now I'm going to check for canceling. I see that I have 4s that I can cancel out. What that leaves me with is minus 12 over 5. Example C, I've got addition and subtraction and some mixed numbers. So the first thing that I'm going to do is change them to an improper fraction. So I've got 5/4. I just did that one in example B. And then I've got 2 times 8 is 16, plus 3 is 19. So I've got minus 19 over 8. So what I notice is that I've got a double sign here. So I'm going to replace that with one negative sign. And I also have to change my denominator to make it match up with the one in my second term. So here I've got 10 over 8, multiplying the top and the bottom by 2, negative or subtract 19 over 8. Now that my denominator is the same for both, what I can do is just subtract my numerators and leave the denominator the same, leaving me with my final answer. Let's do some more examples with division and multiplication. Anytime you're evaluating, you always need to remember BEDMAS is important. So in example A here, I have 2 sets of multiplication. That is what I need to do first before I deal with the subtraction sign in the middle. So first thing I'm going to do is check for canceling. So I've got a 3 and a 6. So I can cancel across there. And in my second one, I can do 2 cancels. So I've got 3 and 3 that I can cancel out. And I also have a minus 1 and a 2 that's left over. So now what I'm going to do is multiply across in my first multiplication set. So 2 times minus 2 is minus 4. And then 1 times 5 is 5. Now I haven't done anything with this subtraction sign, so I'm going to leave it there. And then I'm going to multiply my second set of fractions together. So 1 times minus 1 is minus 1. 2 times 1 is 2, which leaves me with minus 2. Now before I continue, I notice I have a double sign. They're both negative. So that's the same as 1 positive. So I've got minus 4/5 plus 1/2. Before I add them together, I need to find a common denominator. In this case, it's 10. Now that my denominator is the same, I can add them together. So minus 8 plus 5 is minus 3, and my denominator stays as 10. My second example, now we've got this exciting exponent here. I have to do that first. Anytime you have an exponent that applies to a fraction, the squared always applies to the top and the bottom. The reasoning for this is I can rewrite minus 3/4 as minus 3/4 times minus 3/4. Now it's turned into a multiplication question. Top times the top, bottom times the bottom. 9 over 36. 9 over 16. Make sure that you are multiplying accurately. And now I've got divided by minus 5 over 8. I have a division sign, so I'm going to change the sign, flip my second fraction, check for canceling. I can do 16 divided by 8, leaves me with 2. 8 divided by 8 leaves me with 1. And now I'm left with 9 over minus 10, which I can rewrite in equivalent form by putting the minus 9 on the top. The final thing that you should be able to do is substitution involving fractions. So here it says evaluate if A is 2/5 and B is 1. So what I'm going to do is make my substitution, 2/5 for A and 1 for B. And then what I'm going to do is evaluate inside the brackets. So 2/5 plus 5/5. I need a common denominator. So now I've got 1/2 times 7/5. Finally, I have a multiplication question. Top times the top, bottom times the bottom, which gives me a final answer of 7/10. So those are some of examples of implementing BEDMAS when it comes to working with rational numbers.